Hey everyone, welcome back to part 2 of type classes. In the last video, we covered some different interfaces for the type classes: functor, chain, apply, applicative. If you haven't already watched that, please go back and watch that first so that you're caught up to speed. Now in this video, we're going to pick up right where we left off, and without further ado, let's go ahead and jump right back into my code editor. So moving along here, let's look at the next assertion, where we say, given the user option, I want to map over the first and the last name, combine them into one, and then in the next map, I want to uppercase it, or scream and shout that person's name. Okay, so we already know over here that it's passing, but just to prove it, I'm gonna nix doe here, save that, and run it, and then you'll see it fails because it's expecting John Doe. So if we come back over here and we add it back, run our test case again, you see we're passing to change the value to. But what option's doing for us behind the scenes is it's encapsulating two different paths. You can have a sum where the value exists, or you can have a none where it doesn't exist. So if this were actually none and we didn't have the value that we were expecting, this is going to short circuit and it's just going to ignore these altogether and return an option of none. And we can prove that by saving this yarn test, and you'll see it fails because it's expecting a none. Now this is great because it catches areas of our application where the value might be null or undefined. Let me go ahead and fix that real quick. Put it back the way that it was, save it, clear, make sure that our tests are good before we continue moving on. Let's move on to explore the test coverage around chain. So I'm gonna come down here, expand this. All right, now you see I have an option of John Doe and Jane Doe. And the first assertion, what we wanna do is we're going to take Jane Doe's option and we're going to check for the favorite quote within. Now, let me pause and come back up and see what Jane Doe is composed of. So she has an ID, an account balance, first name, last name, email, and favorite quote. Now remember, we said favorite quote is possibly null or undefined, right? So in order to safely map over that value, if that's what we want to pull out, we have to first check whether or not it's there. So we end up with this nested structure right here where we have an option up top, and then underneath that, if we do this O from nullable, that's going to check, hey, is this value there or not? And if it is, lift it up into an option sum, and if not, make it an option none. And what chain is going to do is it's going to take that option of, let's say, string, and before we chain it, if we were to just use O from nullable, we would have an option of an option, and chain's going to flatten that to be one level. So we'll get rid of that, and now we're back to having an option of string, and we can prove that by just doing this identity here, where we return whatever it is in the pipeline at that time, and we can hover over it, and you can see that X is an option of string. Now we're back in the happy path, and we can safely map over that if it's a value, and then in the next map we're going to add who that favorite quote came from. This is just a contrived example of some new business requirement that our application needs to handle, where we're going to tag all MLK quotes. Okay, let's go ahead and run this test. And as you imagine, as it stands, it's going to fail because it's asserting that the valuation is going to equal foo. And it doesn't, so what we'll do is grab the value that it actually is. We'll come up here and create this expected value to equal this. Whoops. Sorry. Okay, now we'll take that expected value, put it in here, save that, clear this out, run our test again. We should be passing, and we are. Good. Now let's go ahead and look at the next assertion. Okay. Now if you notice something here, we have the same exact functionality happening. Now this is the beautiful thing about using pipe in general, or really just FP in general. Whenever we have these declarative pipelines of function composition, we can easily plug and abstract common functionality that can be used again throughout our applications. What we're going to do is go ahead and take the functionality of this pipe. We're going to come up here above our testing block, and we're going to create this new function. We call it option quote, and then we have our pipe, but what we're going to take in is a user option, which is an option of user profile, right? And then we're going to use that instead, save that. Now we can take that function, come back down over here, and we can simply replace this entirely with user Jane's option. I'm gonna go ahead and get rid of that, and let's make sure that we're still passing. Oh, sorry, I need to first comment this out because I haven't changed his. Okay, so I do that, and boom, we're passing. Now we can go ahead and comment his back in, remove this, because remember, we've abstracted this functionality into this function. So we reduce the lines of code. And here we have John's option, and again, it's foo. Now, let's see what happens whenever we run this. So first I'm gonna clear it. Yarn test. Okay, we're failing, but we're failing why? Because remember, John doesn't have a favorite quote. Only Jane Doe does. But our application isn't gonna blow up whenever we fold this out in production. And I'll show you what I mean by that. So let me come back over here, and just to get this passing, I'm gonna head and set that to none. Yarn test, and just make sure that we're passing again. Okay, so what did I mean by folding that out in production? Okay, so let's just say that we're in the logic of the component, right? Where you're going to render stuff. And let's say that we have this function right here where we're trying to map over a user's favorite quote. And that favorite quote may or may not be there. So right here, we know that we have an option of string. Now, in order to get that value and do something with it, we have to pull it out, right? So what we have to do is something like this, where we fold, and you can see that it's already complaining. And it's complaining because we haven't supplied yet the next branching logic. So with option, you can either have a none or a sum. So right here, we have access to that string, and we could do what we want with it. And now this satisfies the requirements of handling all known states for that data structure or that algebraic data type. So in here, we know that for sure at this point we have a string and we can do something. So when I say whenever you fold that out in production, this is what I'm referring to, where these ADTs force you to cover those possible states. Okay, let me go ahead and clear that out. Now we're going to step into, again, some more advanced territory, but for good reason, because I think you'll like what you see whenever you see us put this all together and what we can do with applicatives. So here in the test block, we say that apply can handle sequential composition with an ADT's applicative implementation. Now, what do we mean by that? Okay, so let's go ahead and uncomment this stuff. Right, now here's our assertion. Okay, let's take a look again at those imports, because you see how we have this o.sum and then app.sequence_s. So up here, we're importing everything as app from the apply module in FPTS, and then everything as O from the option module. So let's jump back down here. And you can see right here, we have this app.sequence S. Now, if you read the test, it says apply can handle sequential composition with an ADT's applicative implementation. So what we're doing is we're supplying this method options applicative implementation. And essentially what that's going to allow us to do is compose in sequence these different operations down here from 87 to line 89. And let me get rid of this for a second so I'm not jumping the gun. So what the sequence is going to allow us to do, it's going to allow us to lift these two different operations up into the option ADT and run them both. And after they've both evaluated, then we're going to get an option at the end of that where we either have some or none. So before we run our tests, let me go ahead and prove this to you by doing like we've done above, where we leverage TypeScript's type inference to tell us what the value or what the type of something should be in a particular part of our composition. So if we hover over this X, you can see that we have an option, and inside of it is a record holding John's quote and Jane's quote. Now, if either one of them fail, we're going to get a none. But if they both succeed, then we'll get a sum. And we can go ahead and prove this by running the test. Let's go ahead and clear this out. Run the test. Okay, and they fail. Just like we said before, if either one of them fail, then they both evaluate to a failure or on none in this example because we're using option. So what we could do to self-correct here is we can do this fun thing where we say get or else. And this takes a lazy function. And here we'll just say default quote. Can't spell. Right, and then we need to package that back up into a sum. So get or else here is essentially like low-get if you've ever used that before, but it has way better type inference. So it says if you've given me a none, then I'm going to default to this default quote. Otherwise, I'm going to use the thing that you gave me and I'm going to pull it out as well. So no matter what, whenever we get to this part, this right here is going to be a string, which is why we package it back up into a sum so that it satisfies the criteria for what it takes to wrap up two functions in an algebraic data type in sequence. So now whenever we run this test, we're going to get a different result, right? So we'll go ahead, run the test, and it shouldn't be o.none anymore. Actually, it still is because I haven't saved. Let me save, clear this, and run it again. Okay, cool. So now they're both evaluating, and you can see that the onSum has her quote, and then the onSum for John's quote contains that default right here. So where we said, hey, let's go ahead and fail gracefully here. And actually, instead of failing at all, we're just going to supply this default value instead. Okay, let's go ahead and fix this so our test is passing again. And we're just going to come in and grab this expected quote so we don't have to type all that out. I'm going to put it up here. Move this back over. Let's give us some space so that you guys can see everything. Oops. Okay, and now what we want to do is match what was in the test case. So first we're going to start with Jane's quote, which should be expected. And then for John's quote, it should match default quote. All right, gonna save that. And now we'll go ahead and run this again and see if we're passing. All right, cool. There you have it. Okay, and just to hammer again on the point here of what this buys us whenever we fold. So if we come into this pipeline and we do our fold, here we'll have our error case, and then here we'll have our values. And our values, you can already see TypeScript is inferring that we can destructure here and we can pull out some values. So right here, what do we have available? We have John's quote and Jane's quote. And here, for instance, we could like safely set the state of our component. And then in here with the error, we could, display an error message if we want it. All right, now for good measure here, I want to go ahead and pull in a mapping operation. And I want to show you that what we're doing is we're passing in people, which is the object here, and we're going to spread it in because we don't want to touch Jane's quote in any way. All that we want to do is uppercase John's quote. So if I go ahead and get rid of this map for now, save that and run this, you'll see that we're failing because it's different values. This one is expecting all caps now. So let me go ahead and bring back this fold in. I'll clear this out. And you know what? Just for consistency's sake, let's go ahead and make that test case pass first so you can see how we fix that. Cool. Now we're passing. So let me go ahead and pull this back. Clear this out. And now I want to go ahead and take the time to explain again what's happening. And let's pretend like this is production code, right? So first we have this entire sequence block. And it's not limited to one or two different operations. You can keep going as much as you need. So after that evaluates, it looks at all of them. And if any one of them fail, it's going to short circuit the rest. So if we get a none after this has passed, right here at this level, if this is a none, it's going to skip the map and it's going to jump straight down to the fold, and it's going to go into the on none. And then right there we can safely display an error or what have you. Otherwise, we'll start back up at the top, and if the sequence block succeeds entirely, then we're gonna do our map because we're still on the happy path, and then we're gonna jump into the fold, and then we'll be in the on success case down on line 109 to 111. And again, the beauty about this is that it forces you as the developer to account for all possible states that this can be in a very declarative fashion, so that you don't have to do a lot of defensive programming with if and else if blocks and what have you. And it definitely reduces the lines of code. Okay, I'm gonna go ahead and remove this fold so that our test case pass, and if you decide to pull this down and run it yourself, you don't come into some broken tests. Now, as a bonus example here, I wanted to touch briefly on something that I mentioned before, where applicatives allow for sequential and parallel composition. And we're not going to run any test here. I'm going to go ahead and remove this terminal block, or actually I'm just going to move it down at the bottom. Okay, and I'm going to scroll into view this example right here. So it says that we can handle parallel composition where the provided ADT supports it. Now this T right here, way up at the top, I'm importing task because it has an ADT that supports, it has an implementation of applicative that supports parallel operations. So you could see we have a sequential example and a parallel example. Now I'm just going to talk to this at a theoretical level because depending upon what benchmark tool you use to run this, you may get some inconsistent results, but in theory this is how it works. So a task at a high level is like it's representing a promise, but it's something that won't fail. If you have the possibility of failure, there's a better ADT called task either that you can use, but that's neither here nor there, but I promise we will get into that in another video. So if you look at the sequential example, this will evaluate in roughly 300 milliseconds because it does 1, 2, 3 in order, in sequence. And then the parallel applicative does them all at once, and they all three evaluate in the same time span. All right, I know that was a lot, but now that we've covered ADTs, we've done the technical deep dive there, We've talked about type classes. We've done that technical deep dive as well. I just want to say that the more you become familiar with these data types and these type classes, the better you're going to be at identifying patterns in any type of application that you jump in. And it's going to help you better model your data, the data that's flowing through your application, and the behavior of how that data needs to integrate with existing state. Honestly, this is going to allow you to dominate an app's complexity. No matter what you walk into or what you inherit, you're going to have these very robust and powerful patterns to bring along with you to each project. And I promise it's going to make you a better engineer because of it. And whenever I say dominate an app's complexity, what I'm referring to is it's going to allow us to bend that complexity to our will by repackaging these data types into these ADTs and using these common methods off of these type classes for handling all sorts of desired behavior. That's going to be it for this video. I know that this one was a little lengthy. This one and the last one is probably going to be more lengthy than the ones to come, just because these two concepts are so important and so crucial for laying the foundation of what you have to build on now. But in our next video, whenever you come back, we're going to go ahead and work on building out some form validation using that either ADT that we talked about in the last video, and we're going to leverage a lot of the things that we touched on today as well. All right, so thank you guys again for coming, and I look forward to seeing you in our next video. See you.